showed you the path going down that separated carbon dioxide into carbon and oxygen. These are separating critical points in the Laplacian. So it's a lot of information there, but I think it's a beautiful picture. It reminds me of something some abstract artist in France would have drawn. Okay, so this is what we do. We figured out a good way to do this is what's called volume rendering. Volume rendering, we take a cube and we calculate the value of the Laplacian, the lumpiness, at every point in that cube. Billions of points. And then we use these sliders to, like a microscope. If you're taking microbiology, you're looking at a cell structure, you have a focal plane. You know, you adjust the focal plane. If you're looking through the eyepiece, you go through different organelles. You know, different parts of the cell come into and out of focus. Anybody done cell biology? You can see different parts of the cell by moving the focal plane. So what we do is this sliders allows us to look at lumps, holes, and I'll show you some movies. But what we do is we just move different parts of the molecule come into focus and out of focus by changing the opacity. Okay, so some colors are opaque. The rest of them, like over here, you see the cube here, is transparent. So we can make different data points opaque or transparent by using the sliders. Just like a microscope, you move the focal plane. Some things come into focus and you can see them. Other things are out of focus and you don't see them. So the colors, we need to use colors. Why not use colors? So green, cool colors, green and blue, represent the holes, like the dents, where you have a bit of a dent in an atom. It's a cool color. So you see all these little blue balls here? All those blue balls, those are carbon atoms. They're blue because that is the region between the core, the nucleus, the 1s, and the valence. So in between the 1s and the 2s, there's like a moat. There's like a place with a hole. There's blue. Okay, so it's like my neck. I haven't been I still have a neck, but there's a positive curvature there. So there's electrons there, but they're positive curvature. They're like a hole. And the warm colors, red and orange and yellow and white, so you probably can't see them, but the center of those blue balls, there's a little white peak, a little bit of ugali, okay, right in the very middle there. That's white is hot, so that's where the 1s electrons are. You can't see them because they're very nuclear. The cores are very small. Then you have these red areas, those little red thumbs. Okay, those are hydrogens. Because hydrogens have if they're forming a covalent bond, it's got two shared electrons, and they're fairly constant. They're a lump. They make a lump around the hydrogen atom to make a covalent bond. So you see all these thumbs, red thumbs. Those are covalent bonds. Now hydrogen doesn't have a blue ball. Hydrogen doesn't have a blue ball because hydrogen has no core.